Hi, my name is Nixie, and for today's lab, we're going to do measurements and uncertainty for chemistry 1406. Let's get to it. Okay, so for this lab, we're going to need quite a bit of equipment, and the first thing that we do need are plastic cups, 2. We need our thermometer. This one is a glass thermometer, so be very careful with those. We need our 250 milliliter beaker. We also need a 25 milliliter flask. This is also glass, so be very careful. 10 milliliter graduated cylinder, along with the 50 milliliter graduated cylinder. So you do need 2 cylinders. And then lastly, you need a scale that is in grams or ounces. I believe for this experiment it is in grams, so I would get one of those. So our first step is going to be labeling our cups, cup 1 and cup 2. So after you have labeled cup 1 and cup 2, turn on your balance and select what mode you want it in. For this lab, I will be having it in grams. After that, you have to make sure that your scale is in a stabilized position at 0.00. Next step would be to place cup 1 on the balance completely, and you would record this number 10.01 in your chart given in your lab manual. So after you have recorded the mass, you will take your cup 1 off and let it restabilize again to 0.11, and you will repeat this process an additional 4 times. After you have recorded your mass in the table, you will repeat this process 4 additional times. Between each step, you will remove your cup, let it stabilize at 0.00, and then once again, place it on the balance and record the mass. After you have recorded all 5 masses on the table, you will repeat the same process with cup number 2. So put it on balance and record that mass. You record each mass of cup 1 and cup 2. You will find the average. To find the average, you add each mass up 1 through 5 and divide by 5, since those are the number of trials. Next, to find the deviation of average, you will use the formula average mass of cup minus mass of cup in trial. This is what your final chart should look like. Now for activity 2, we do need our balance, our 2 graduated cylinders, water, our flask, and our beaker. So for our first step, we need to turn on our balance, stabilize again at 0.00, and put on our 10 milliliter graduated cylinder and record that mass again in grams on our table provided in our lab manual. So the next step is taking the graduated cylinder off and measuring approximately 7 milliliters of water in the 10 milliliter cylinder. The next step would be finding the high volume, and the high volume is at the highest point of your measurement. So as you can see here, it's not exactly on 7, so my high volume is at 7.2. After that, you will have to find the low volume, which is at the lowest point of your measurement. It usually is pretty similar to your high volume, and my specific low volume is 7.1. The next step would be to stabilize your balance at 0.00 and put on your graduated cylinder with the 7 milliliters of water and measure the mass in the table given in your lab manual. Next step will be to repeat the process with the 10 milliliter graduated cylinder and also balance and water. You will need those measurements for your table. The next step would be to stabilize at 0.00, and with your 50 milliliter graduated cylinder, you would be weighing that and recording the masses in your charts. The next step would be to fill the 50 milliliter graduated cylinder with 24 milliliters of water approximately. Next, you will solve for the volume high and low, and for mine it is 24.1 for the high and 23.9 for the low. Next, we will turn on the balance and weigh the mass with the water in. and record on our chart. Next step would be to repeat the same process again for another trial and record your calculations on your tables. Next, we'll repeat the same process with our 25 milliliter flask. Lastly, we will do the exact same process with our 250 milliliter beaker, and we will add 55 milliliters of water in this container. Your chart should look like after you find the mass of each activity. To find the uncertainty, you need to do high interval minus low interval divided by 2, and for measured value, you need to do high interval plus low interval divided by 2. For the third activity, you will really only need your thermometer and the chart's information used in the previous activities. The first thing you need to do is read the room temperature. Specific to me, it is around 22.8 degrees Celsius or 73 degrees Fahrenheit. Using the temperature of the water, you will find the density of water at room temperature with the table provided in your lab manual. Our last step would be to find the calculated volume of water. In order to find that, you must use the formula density equals mass divided by volume. You would use the mass from the previous activity and the density found in this activity.